Compare the potential energy of reactants and products by examining the potential energy diagram, reaction profile. The horizontal line representing the reactant, XY2, lies at a lower potential energy level than the horizontal line representing the products, X plus Y2. Determine the reaction enthalpy. Delta H. The net change in energy for a reaction is the difference in potential energy between the products and the reactants. Delta H equals H products, H reactants. The vertical interval representing this difference is annotated on the far right of the diagram as 50 kilojoules per mole of reaction. Classify the thermodynamic nature of the reaction. Because the potential energy of the products is higher than that of the reactants, energy must be absorbed to drive the reaction forward. This positive enthalpy change, delta H equals plus 50 kilojoules per mole of reaction, characterizes the decomposition as an endothermic reaction. Determine the direction of heat flow. An endothermic reaction absorbs heat from its environment to overcome the positive enthalpy change. Therefore, heat is transferred from the surroundings to the chemical system. Calculate the heat transferred for 1.0 mole of reactant. According to the balanced chemical equation, 1 mole of XY2 decomposes per mole of reaction. Heat flow equals 1.0 moles XY2 times 50 kilojoules per mole of reaction equals 50 kilojoules. Thus, 50 kilojoules of heat is transferred from the surroundings, matching option B. The correct answer is option B. 50 kilojoules of heat is transferred from the surroundings.